So this is the final task we're going to be talking about in disassembling Python bytecodes. So under if and else statements. So we're asked to write a Python function called magic calculation. It accepts three parameters, which is A, B, C, that does exactly the same as the following program bytecode. So that is what we are asked to do in this case. So actually I'm going to be creating the file called this stuff here. Just gonna do that right away. Then also we are going to have our main file. Actually in this case you don't need a main file, but I'm going to add that just for testing sake to see if it works exactly. So without wasting much time, we are going to go ahead and start business. So let's start it. So all this because we don't need it. So let's screenshotted that so that I'll have a copy of it and I'll be able to access it easily, because that will be very important. So just wait for it to load. Because that's the most important stuff. So we'll get the Bytecode right away. So I'm just going to scroll to the last part of the page. So this is the whole Bytecode we are looking for. So I'm just going to zoom in, and I think I'm going to snap that. I just pray it's not blocked. Let me see if I give it a screenshot. Actually, it might not respond. Okay, I think it responded this time around. So lucky for me. So for it to shut the screen. Now just open that with camera so that I can view it without refreshing, waiting for the browser to load. Actually, things here starting to become too heavy, so I just know how to manage space. Yeah, so this is it, and this is the actual thing we just need. So I'm just gonna leave this place and go to which is this part now. In my editor, I'm going to whatever we have here, and I'm going to navigate inside desktop. So I'm also going to navigate inside LX high level level programming. Then I'm going to also navigate inside 0x01. So that's it. Now that we have that done, we can now place what we have there. So this is all we have there. Clear the screen and list it one more time. So these are the stuff we have here. So we stopped at 101, so we create the next one, which is VI102 magic calculation. So just hit enter and boom, we are inside there. Now that we are inside there, I'm just going to go ahead and start typing our code. So exclamation mark slash so now that I've put that, I can go ahead and put USR slash BIN slash EYTHON3 like that. So in that case, that is settle. So I can come in there and put in my function. So I think I should paste this again. Then I'm just gonna get rid of this DEF, define magic calculation. I don't know whether that's how I call function. I can't really remember. Okay. But at least I know it has A, B, and C. So make sure you check the type very well before we go ahead with further calculations. So just like that. Now we are good to go. Now I can just put I can just leave it like this. Then I'll decide to go outside there to check my file to see or to test it if it brings out the same code or bytecode. So I'm just gonna exit this and I'm going to create a main file. I'm gonna call it 102-main.py, just like that. Now I'm just going to hit enter. Now I'm going to type in this slash USR slash BIN slash EVN then I just want to be sure if I'm correct. So the next thing I'm going to do is to import. I'm just going to call it tests. That's what I'm going to call it. So I say equals to, then I put my underscore imports, then underscore, then parentheses, just like that. So in it, I'm gonna put the name of the file there. So just paste I'll remove this py. So in there, I'm gonna access the function. So that is there, but I'm gonna get rid of this magic because the name of the function is magic underscore calculation. That's the name of that. So I'll go over to the next line. Then I'm also going to import this so I want to see how this is gonna work. DRS, but before I go ahead and do that, let me exit this. So I would love to confirm something. So to check a Bytecode, use a disassembler that is going to disassemble your code. So we're going to put it there. So I think I'll wait a little bit. So we have Python disassembler / Bytecode like that. So wait to load and see what we are and what we are making use of. So now you can see we're making use of this or this. Then the name of the function. Then it's going to give us our Bytecodes in line. So that's what I wanted to check out to confirm that. So I'm using to get back. So I'm going to say this actually this this. Then I'm going to open the function. Then inside it I'm going to pass test inside the function parenthesis. Now I am going to put WQ there. Now I can go ahead and change the mode like that. U plus X, then 102 main, so just like that. So let's see. So we have 102 main. So now we might decide to run that 102. So okay. So we might want one thing to correct there. So I'm not sure whether it's EVA. So I'll just make sure I activate it. So now let me go up and check what's there that we need to add to make it complete. So Okay, so it's ENV, not EVN. It's I use ENV. So let me go and rectify that. So go up here and put the ENV. So let's see if we have any other issue again. So recently whatever in line 2 in models magic calculation. So was expecting an indented block after function definition on line 2. So I think I need to open this file to see. Okay, so they were expecting an indentation here. So actually I've added the indentation. So I'm just gonna leave here and execute it again. So actually there is no need of doing that because it won't really work out. So the solution here is to start writing or interpreting those codes, then start seeing the outcome, because there's nothing for it to bring out. So now when we take a look at here, we have load fast. When we look at this image I'm going to open, we have a load fast there, starting from 3, load fast, then under that place, A, which is one of the parameter that was passed into the function, then B, another parameter passed into the function. So they use a less than to compare them. So we're compared. So then pop jump if underscore false, which is 16. So that means if A is less than B, so it's an if statement. This is what's the first block under 3 is explaining. Now under 4, after the if statement, the next bit of code is load fast C, then return the value. That means we should return the value of C whenever A is less than B. So that's the first stuff we're going to do in there. So I'm going to go to a magic function over here and start typing out some stuff. So if A is less than B, then I want you to return C. So just like this. Now let me check that and see. You can see actually something is printed out now because I've provided a very useful information. Actually it ought to be more like this, but you can see it. I zoom it out. We have 3 there, and it's giving us load 0, load fast, load underscore fast. Then we have 0 A, and we have load fast again B, this line of code. Then we have 4 here, which is P opposite, which is 0 is less than. You can see that part. Then compare compare, where it's going to compare. There's an if statement. So whenever you are reading the bytecode, you start from after that bottom, then start going to the top. That's going to be reading for you to understand. So you say if, you understand? If A is less than B. See, you can see that. You see I'm reading that. So you are going up and down. If A, which is if, then to the top A, then back to the bottom, which is the next one, is less than, then 2B. Then you come to number 4. You start again from the bottom. Return, then to the top, C. I hope you didn't get that, but let me explain that again. I'll come to this first part and read. Then to the top, A, you can see that is less than, then to the top again, is less than, you can see that. Then that is for all this interpretation was this number starting from here and ending here. Now going to number 4, that's the next line. That is on line 4. I want you to return, then return is what value? The value of C. So you can see I have interpreted that line. So you can go ahead and compare it with the one we have there on the gallery to see if they are the same. So we have 12, and we have 15, we have 9, 0, 3, 6, 9. So our own, there's a bit difference there. It's reading it to 4, 6. So based on your bits architecture, so it depends. If you are using a system, it reads on 3. If you are using a phone, it reads on 2, but it's still correct. So like my own is going 0, 2, 4, 6, 8, 10. Your own is going by 3. So it's based on the speed of your system or the architecture design of your system, whether you're going 32-bit or 64-bit, whichever. So that's what warrants whatever thing to be the same. So that is for line 4, on line 3, and on line 4. So that is set, like really settled. Now you can go over to your code. So I would like to navigate back again to see. Now let's set a number. Sorry, escape. Let me set a number so that we'll see which line we are. Number. You can see. You know that the if statement starts on line what? On line 3. It's less than B. Then the other one is on line 4 and return C. So you can see how it goes. So both the lines are there, and whatever stuff at all are still there. Now let's go ahead and read the next one there. Now on line 5, that is the 5th line, load fast. I want you to load fast CD. So let's start from the bottom. An if statement again. So whenever you see that 2 greater than sign, you see after that 5, number 5, that line 5, you see 2 greater than sign. It means that it's still under the function. Whatever I'm writing is under the function, still in the same indentation with the after the function. So you can see that after defining magic calculation function, which we did here, and we have a, b, c, there was an indentation before the if statement. So the first indentation, where we have if a is less than b, is giving that two right greater than sign. Two greater than sign. We have now every other code from line 3 to 4 falls under that. Now the next code is trying to tell us that we still that same indentation from the function. So we have 16 load fast. So let's read from the bottom, that is from 25. If, then go to the top, C, then bottom is greater than, then top, B. So you can see I'm reading it. If C is greater than B, then what's the next thing? Let's go to line 6. Now line 6, you notice that on line 6, there was no greater than sign. That is the arrow that is pointing to the right hand side. That means it's not on the same indentation. That means you are going to create an extra 2 indentation that will be inside the if statement. So it's a return statement. Then let's read from the bottom. Return. So let's solve that from. Let's solve that offline first. If C is greater than B, so let's say that if C is greater than B, if C is greater than B, so just like that. So on that line, with on line 6, load underscore fast, A. So okay, let's read 6. Return the value, which is 35, then go back to the top, which is 28. Load fast, which is A. Return the value A, then come down, plus, that is binary add. Whenever you see binary add, it simply means plus load fast B. We're going to add A plus B. So return the value A plus B. So the value A plus B. So return A plus B. So you cannot just leave it this way. Let's put it in a bracket to make it look more clean. So now we have ended the statement there. Now let's read line 7, what we have on line 7. Now on line 7, we have greater than sign. So let's look at the last thing there. On line 7, that is 47, we are returning a value. There is no if else statement there. So I thought you start from the bottom, top, bottom, top, bottom, top, bottom, top till you get everything. Return value. What are we return value? Return the value of A, which is A there. Then bottom again, binary subtract. So we're going to subtract oops. Okay, so we're going to subtract from B, isn't that? Then we have C, we are going to multiply it with. Wow. Okay, let's see whichever one works. This time around, still returning. So return the value of A. I think it should be A times B. So let's do it first to see A times B, because times come next. A times B. right? A times B. So A times B. Then load fast C subtracts. So we're going to subtract it from load fast C. We're going to subtract it from C. So I'm going to put minus C there. So just like that. So like this, away from that. So let's see if our Bytecode is going to give us the same output. So let's run it. Okay. Now let's look at on line 7 we have load fast A, load fast again B, then binary multiply, yeah. Then we have load fast, which is 2 C. Then the next thing that comes in is binary subtract, then return value. So that is correct for line 7. Now let's look line 5 and 6. Okay, we have 14 to 28. Let me check that. 14 to 28. I think there's a bit difference here, especially on line 5. On line 5, we're supposed to have line 5. We have 214. Let's see. 214. But at 16, my increase to 6. My own increased. My first return value was 6. Okay. Okay, my own is going 6 to 12. 4 to 28. So it just depends on my phone how I'm working, because any place I put the if statement, I think it's returning to value 6, then open bracket to 12, and I'm seeing 14, open bracket to 28, so like that. So it's just a little bit of difference based on the device that I'm using. So you can see, so this is everything for a Bytecode compiler. So you're able to read this and understand. You can even convert this back to its normal code. Yeah. So make sure you like, subscribe, and share. So this is the last part for the if and else loops and